my PU2 aspirants. So yes, we just have very few days left for our exam, right? And yes, now we have started a marathon series where we are going to discuss all the important 1 marker, 2 and 3 marker and 5 marker questions. So in today's video, I will be discussing the most expected, most important 2+3 marker questions that will be asked in your PU2 chemistry examination. Okay, so let us start. So I want all of you to sit with a notebook and pen and make a list of all these important questions. Now these important questions have been taken from previous year questions, your pre-board papers of all the districts, exemplar questions and some HOTS question as well. Okay, so let's start. Let us understand the question pattern. So we will be getting 2 marker questions in section B. Okay, so which all chapters will be there for 2 markers from section B? One second. Yes, so you will be getting 5 questions in section B, out of which you have to attempt any 3 questions. Now these 5 questions will be, one will be from physical chemistry, that can come either from solutions or from chemical kinetics. Okay, different model papers have given different, so one question will be either from solutions or from chemical kinetics. Next 2 marker question will be from either from coordination or from DNF block. Okay, next we will get 1 question from haloalkanes, 1 question from alcohols and 1 question from biomolecules. This part is clear? Okay, next moving to section C. So in section C you will get DNF block questions, coordination chemistry questions, solutions, electrochemistry and chemical kinetics. So you will get 1 question from solution, 1 question from chemical kinetics, 2 questions from electrochemistry. Here this can be 3 questions and this can be 2 questions, or it can also be 2 and 3. Okay, so I can say roughly you will get 5 questions from here and 4 questions from physical chemistry. I hope the pattern is very clear. Okay, now we will move to solutions chapter, where I'll be giving you 3 marker questions. Now see, in solutions chapter, the 2 marker and 3 marker questions can be asked in any way. Like a 3 marker question can be asked in 2 marker form, 2 marker question can be asked in a 3 marker form. So I'm giving you all the possible questions that can be asked. So you, any marker question it comes, whether in 2 marker or 3 marker, you can easily attempt the question. Okay, so I have written here 3 marks, but yes, it is applicable for 2 marks as well. Let us see the first question here. Mention the factors on which the solubility depends. Okay, very simple question. If it is a 2 marker question, you have to write 2 points. 3 marker question, you have to write 3 points. So yes, what are the factors? Nature of the solute, solvent, pressure and temperature. Okay, very simple and easy question. Let's move to the next question. State Henry's law and writes its mathematical form. What is the significance of KH? Now see, if only this much is asked, state Henry's law and write its mathematical form, that can be a 2 marker question. If we have added something here, then it will become a 3 marker question. Okay, so yes, Henry's law tells about the solubility of a gas, right? It states that at a constant temperature, the solubility of a gas in a liquid is directly proportional to the partial pressure of the gas above the liquid. Okay, here the formula of the Henry's law is P is equal to KH of the gas. So I will write the, so whenever you write the mathematical terms, please mention the meaning of the terms. Okay, that is very important. What is P of the gas here? Partial pressure of gas. Okay, partial pressure of the gas. Next, KH is what? KH is Henry's constant. Okay, then X of the gas is what? Mole fraction. Okay, mole fraction of gas. Okay, next the question is, what is the significance of KH? The significance of KH is whenever KH is more, solubility will be less, and if KH is less, solubility will be more. So higher the KH value, less is the solubility. Okay, so that is your 3 marker question here. So this statement carries 1 mark, expression and the definition of the terms carries 1 mark, and the last one carries 1 mark. Let's move to the next question. At a given temperature T and P, N2 is more soluble than helium in water. Whose KH value is more? So now you see, N2 is more soluble, He is less soluble. So definitely KH value of He will be more. Aquatic species are more comfortable in cold water than in hot water. Why? So you know, for gases, okay, so for gases the solubility of gas in a liquid, if we consider, if the temperature is less, solubility will be more. So in cold water more gas is soluble, more oxygen will be soluble, more dissolved oxygen will be there, so animals can breathe properly, so that is why they are more comfortable in cold water. So first of all, the first thing here, He is less soluble, so it will have more KH value. In cold water more oxygen is dissolved, that is why they are more comfortable. Next, give 3 applications of Henry's law. This is very common question, you know, scuba divers, then you have carbonated drinks, scuba divers, and using when the people go to higher altitude they face difficulty in breathing, that is also because of Henry's law. Okay, so here even 2 applications can be asked, it can be a 2 marker or a 3 marker question. Next, explain the cause of bends in scuba divers and how it is controlled. This is a very good question. So this question can be framed in many forms, like it can be asked why scuba divers tanks are filled with helium. Okay, so anything, questions can be framed around this particular concept. So let us understand the concept here. So what happens when we go down the ocean, okay, or seabed? Pressure is increasing, and Henry's law says that more is the pressure, more will be the solubility. So when you go, suppose this was the surface, okay, you went down till the bottom of the sea, pressure of the atmosphere is more, solubility of the gas will be more. Okay, so more amount of gases will be soluble in the blood, and especially the nitrogen gas gets more soluble. That is fine. Now when you come up, okay, when you come to the level, you won't be staying there, right, you will be coming up, so the pressure is decreasing, then the solubility will decrease, so N2 gas which was dissolved in your blood will come out of the blood vessel in the form of bubbles. Now these bubbles can block your veins, arteries, and can cause severe pain, leading to a medical condition called as bends. To avoid this, what we do, we add helium to the oxygen cylinders of the scuba divers. How does it help? Now just now we see that helium is less soluble than N2, right? So less amount of helium will be go to the blood, so that if less amount is soluble, less amount will come out, so that problem can be avoided. Okay, so you can see here I have given little big answer, but yes, to explain it properly you can write down in this form. So explain the cause of bend. So first of all, as scuba divers go down in the sea, pressure increases underwater. So what I have told, I have just written it. Now increased pressure increases the solubility of nitrogen in the blood. When the divers comes to the surface, the pressure gradually decreases. This releases the dissolved gases and led to the formation of bubbles of nitrogen in the blood. This blocks the capillaries and create a medical condition as bend, which is very, very painful and dangerous to life. So understood what is the cause of bend, we understood. Next, how is it controlled? The avoid bends, the tanks used by the scuba divers are filled with helium. Okay, so you have to remember the percentage of helium: 11.7% helium, nitrogen 56.2%, and oxygen 32%, because of the low solubility of helium in the blood. So if helium is not there, then you can see almost another 10% nitrogen will be there, right? So that is why to reduce the amount of nitrogen we are adding helium, which is having lesser solubility. Okay. Next, state Raoult's law. So now we were discussing about the solubility questions related to solubility. Now we have something, vapor pressure of the liquid solution. So you know Raoult's law and vapor pressure questions we will be discussing. State Raoult's law and gives its mathematical form. This itself can be a 2-marker question. Next, what is vapor pressure? Vapor pressure of CHCl3 and CH2Cl2 are 200 and 415 mm of Hg, which is more volatile. Okay, this mixture can be made and can be asked you in the form of 2-marker and 3-marker question. So what does Raoult's law says that? Raoult's law say that the partial pressure of a gas, okay, is directly proportional to the mole fraction of the gas in the solvent. Okay, in the solution, the partial pressure or the vapor pressure created by a gas above the liquid is directly proportional to the mole fraction of the gas in the liquid. Okay, so you can see here Raoult's law statement. It states that in a solution of 2 volatile liquids, the partial vapor pressure of each component of the solution is directly proportional to its mole fraction. Okay, so mathematical form I haven't written here, I will add here. Mathematical form I can write P is proportional to, or I can write partial pressure of A is proportional to mole fraction of A, or I can write PA is equal to P naught A into XA. Okay, so what is PA? Partial pressure of A. Partial pressure of A. What is P naught A? Partial pressure of, sorry, not partial pressure, pure pressure of solvent A. We have pure pressure of A. Okay, then XA is mole fraction of A. Clear? So that is the first term. Then what is vapor pressure? Vapor pressure is what? When the system is in equilibrium in a closed container, the pressure exerted by the vapors on the liquid is called as vapor pressure. So the pressure exerted on the liquid by the vapor present above the liquid surface when they are in equilibrium with the liquid is called as your vapor pressure. Clear? Next, which is having more vapor pressure, CHCl3 or CHCl2? So you can see here that CHCl2 is having more vapor pressure. That means what? It has evaporated more, it is more volatile, so obviously the answer is CH2Cl2. Okay. Next, why is the vapor pressure of the solvent decreases on addition of the solute? This is very important question, so I can mark this question as important. So all the three colligative properties, okay, the relative lowering of vapor pressure, elevation in boiling point and depression in freezing point. So you should be knowing the reason. That can be asked as a very good question, like why the vapor pressure decreases, why the boiling point increases, why the freezing point decreases. Okay, these all things, three questions you must remember, it can be asked. Okay, so what happens to the vapor pressure of the solvent? So you all know that vapor pressure is caused by the phenomenon of evaporation. Now when you add a solute to it, some of the surface particles are blocked by the solute particles. So now less amount of molecules will go to the vapor phase. So that is why the vapor pressure decreases. So you can write out in your own words. So in a pure liquid, the entire surface is occupied by the molecules of the liquid. If a non-volatile solute is added to a solvent to give a solution, the vapor pressure of the solution is solely from the solvent alone. Okay, so it will be only because of solvent. In the solution, the surface has both solute and solvent molecules, thereby the fraction of the surface covered by the solvent molecules get reduced. Okay, now for example, if you have pure solvent, okay, and this is the level. So we have 1, 2, 3, 4, 5, 6, 7, 8 particles were there in the solvent particles. Now what you did? You did some solution and you added solute to it. So what will happen now? Okay. Now you see certain particles are now covered by the solute particles, right? So now these solute particles will not evaporate, only the solvent particles will evaporate. So that is why the number of solvent molecules escaping from the surface is correspondingly reduced, thus the vapor pressure is also reduced. Okay. Next, what is ideal solution? Give example, draw the graph of the vapor pressure against the mole fraction for ideal solution. Ideal solution is something which obeys Raoult's law. Example, you can give chlorobenzene, bromobenzene and benzene and toluene, heptane, hexane, any two examples you can give, and graph also we can draw. Okay, so examples are benzene and toluene, bromoethane, chloroethane, N-hexane, N-heptane. Solution that obeys Raoult's law. Graph, if you have remembered, this is the graph here for an ideal solution. So please practice this graph. The leveling should be very correct. Xi equal to x1 is equal to 1, x1 is equal to 0, x2 is equal to 0, x2 is equal to 1. Now here what happens? We have x1 is equal to 1, so it is p01, and x2 is equal to 1, so it is p02. So we have p1, p01 to p02, and here this is increasing from 1 to x2 is from 0 to 1 and this is from 1 to 0. So P1 and P2 is there. Okay, clear? Next we will have What is non-ideal solution and give examples? Draw the graph of vapor pressure against mole fraction for non-ideal solutions. So yes, non-ideal solution is which does not obey Raoult's law, and in the graph you have positive deviation and negative deviation. So you can draw. This is does not obey Raoult's law. Here examples are there: HCl plus water, C2H5OH plus water. So this is positive deviation, this is positive deviation, right? This is also C2H5. Okay, let us not mention whether it is positive or negative because it is not asked here. You can just write down any of these two examples. Next graph you can see, this is your positive deviation graph and this is your negative deviation graph. Okay, very easy questions these all are. Okay, next, give the difference between ideal and non-ideal solution. Very important question. Okay, this is very important question. Okay, at least 3 points you should be knowing: obeys Raoult's law, does not obeys Raoult's law, delta H mix, V mix, then AB interactions. About these 4 things we can talk about ideal and non-ideal solution. Next, differentiate between the types of non-ideal solution, that is your positive deviation and negative deviation. So we have here AB positive deviation, AB interactions are weaker. Negative deviation, AB interactions are stronger. P total is more, here P total is less. Delta H mix is positive, delta H mix is negative. Now this point is repeated, we can leave here. Example of positive deviation: ethanol plus acetone, CS2 plus acetone, phenol plus aniline, and chloroform plus acetone. Okay, these are the examples. Next, give the type of deviations with the reason. So acetone and ethanol will have positive deviation. Why? Because ethanol is having very strong hydrogen bonding, but when you put acetone in that, so acetone and ethanol will not have that strong hydrogen bonding. Okay, so then phenol and aniline have negative deviation because of strong hydrogen bonding. Chloroform and acetone also have negative deviation because of strong bonding. Okay, so let us see the first one. As I told you, positive. So what happens in pure ethanol, there was strong hydrogen bonding. On adding acetone, its molecules get in between the ethanol molecules and breaks the hydrogen bonds between them. Due to the weakening of interactions, the solution shows positive deviation. Now coming to phenol and aniline, it is negative. This is because the intermolecular hydrogen bonding between phenol and the lone pair of nitrogen is stronger than the respective intermolecular hydrogen bonding. So you just have to mention that the hydrogen bonding between phenol and aniline is stronger. Next we have what? Chloroform and acetone. So chloroform and acetone is also negative. This is because chloroform molecule can form hydrogen bond with acetone molecule. Okay. Next, what are azeotropes? Give example and mention the type of azeotropes. So here we have azeotropes are binary liquid mixtures having the same composition in liquid and vapor phase and boil at a constant temperature is called as azeotropic mixtures. Okay. Then example, 95% of ethanol and 5% of water. Next, what are the type of azeotropes? We have maximum and minimum boiling azeotropes. Okay, fine. Next question is differentiate between them. So you can differentiate maximum boiling azeotope, they have negative deviation, minimum boiling have positive deviation. Next, talking about the boiling point, so they boil at a temperature higher than the boiling point of the individual elements. They boil at a temperature lower than the boiling point of the individual elements. Example is very important: nitric acid and water. Okay, and here ethanol and water. Okay, so please remember the composition and the examples. Next, we'll go to colligative properties. So what do you mean by colligative properties and name them? So the properties that depends upon the number of solute particles are called as colligative properties. What are they? We have relative lowering of vapor pressure, elevation in boiling point, depression in freezing point, and osmotic pressure. Next, when does liquid boil? What is ebullioscopic constant and what is its SI unit? So liquid will boil when the vapor pressure of the liquid is equal to the atmospheric pressure, right? So yes, liquid boils when the vapor pressure of the liquid is equal to the atmospheric pressure. What is ebullioscopic constant? It is the increase in boiling point produced when 1 mole of a non-volatile solute is dissolved in pure solvent. So if you see, delta TB is equal to KB into M. So if this part delta TB is 1 and molality is 1, then the value here is KB. So we refer to that, it is the increase in boiling point when 1 mole of a non-volatile solute is dissolved in 1 kg of a pure solvent. Okay. Next, what is its unit? So it is kilogram. So K divided by, this is moles per kg, right? So it will become moles per kg. Okay. Next we have give the relation to calculate the Kb using the enthalpy of vaporization. This is important question. Draw the graph of vapor pressure with temperature to show the elevation in boiling point. Next, which has a higher boiling point. Okay. So let us see this one. So first of all, this formula Kb is equal to R into Ma into Tb square divided by 1000 into delta H vaporization. So what are the terms here we have? We have M is equal to molar mass of the solvent, okay, molar mass of solvent. Tb is equal to boiling point, okay. Then we have delta H of vaporization is equal to enthalpy of vaporization. Okay. Now R is what? R is your gas constant. Okay. Now see, let us understand this graph. So what happens is, this is your atmospheric pressure. Okay, this line is your atmospheric pressure. Now when the vapor, this is the vapor pressure of the solvent, this is the vapor pressure of the solution. When the vapor pressure of the solvent or any vapor pressure of anything matches the vapor pressure of the atmospheric pressure, at that time we get boiling point. Okay. Now when you add solute to the solvent, we form solution, and solution vapor pressure is less than that of the solvent. So if this is the solvent vapor pressure, solution vapor pressure will be here somewhere, right? So it is crossing the atmospheric pressure at this point, and here we will have delta, or we can have Tb here, right? So Tb is your boiling point, which is higher than the delta T naught P. Okay. Next, okay, here which is having higher boiling point. So here if you see, I factor is 2 and here I factor is 3. So I factor is more here, so definitely Na2SO4 will have higher boiling point. Next, when does liquid freeze? Why is cryoscopic constant and what is its unit? As just similar to the previous question. So liquid will freeze, okay, liquid will freeze when the vapor pressure of the solid will be equal to the vapor pressure of the liquid. Okay. So that is what liquid freezes when the vapor pressure of the liquid is equal to the vapor pressure of the solid. So it is the decrease in the freezing point produced when 1 mole of a non-volatile solute is added to 1 mole of a pure solvent. Next, unit is same as Kb, K Kelvin kilogram mole inverse. Okay. Next, this was a question in some of the pre-board paper. I think it is already, it's visible. I'll read it for you. Scuba divers fill their air cylinders with helium. So just now I discussed the whole thing. Next, addition of small amount of salt in water decreases its freezing point. This is important question. Next, the I value of aqueous KCl is more than that of ethanol in benzene. Okay. Next, we'll see. So first of all, what is the reason why helium is added? Because helium has less solubility than nitrogen. But the thing that I want to focus is on this one, that is, why do when we add a small amount of salt, the freezing point will decrease. Okay, now see, a solution will freeze when its vapor pressure equal to the vapor pressure of the pure solid solvent. Okay, like for example, you have prepared a solution of salt plus water. Okay, and so what is the pure solvent here? Water. Okay, so now this will this solution, okay, this solution will freeze when the vapor pressure of this solution is equal to vapor pressure of solid water. That means that is ice. When these two vapor pressures are equal, we will find the freezing point is taking place. Okay, now what happens? Okay, according to Raoult's law, when a non-volatile solute is added to the solvent, its vapor pressure decreases, and now it would become equal to that of the solid solvent at a lower temperature. Okay, now see, for example, we'll draw a graph, for example, like this. Okay, so this is suppose the vapor pressure of the solid, vapor pressure of solid. Okay, and this is the vapor pressure of the solvent. Okay, now when these two will meet, at that point we will have freezing, Tf, T naught F. Now when you have added a solute, that means what? Vapor pressure of the solution, this is the vapor pressure. When this one will meet this one, this point, you will have T naught F, Tf here. So that is the decrease in the freezing point, right? So that is what is happening here. Okay, next we have, okay, so this question I have given here. So give the relation to calculate the Kf using the enthalpy of fusion. So that we have already R ma Tf square delta 1000 by delta H fusion. It is similar to your Kb formula, just you have to replace delta H of vaporization with fusion and Tf with Tb. Okay, I think I have given that only here. Just let me check once. Yes, so that is the same formula, just you have to change certain terms. Next, draw the graph of vapor pressure with temperature to show the depression in freezing point. Yes, you can see here. So this is liquid solvent and this is frozen solvent. When these two equalize or these two meet, at that time we have the freezing point. Now when you add a solute to this solvent, the vapor pressure of the solution will decrease. Now this one will reach here and then we will get a freezing point which is lesser than the original freezing point. Okay, next let us see what is osmosis and give an example, what is semi-permeable membrane, and give example for natural and artificial membrane. So this can be asked in a mix and match format. So osmosis is the flow of the solvent molecules from a region of lower concentration to a region of high concentration. What is semi-permeable membrane? It is a selective membrane which allows only the solvent particles to pass through it. Now example of natural, pig's bladder can be used as a natural membrane, parchment membrane and cellophane. Okay, so cellophane is an example of artificial membrane. Next, give reasons for the following. Raw mango shrivel when pickled in brine or salt water solution. What will happen? Raw mangoes, it will undergo osmosis, right? So water from the mangoes will go out, so that is why it will shrink. Blood cells collapse when suspended in saline water. Same thing, due to osmosis, water from the blood will move out and the blood cells will collapse. Wilted flowers revive when placed in fresh water. So when you place it in fresh water, water will move into the flowers and it will again bloom. Okay, so you can see the example here. So due to exosmosis, this is also due to exosmosis and this is due to endosmosis. Okay, next explain isotonic solutions with example hypertonic solution and hypotonic solution. So you should be knowing this. Two solutions having same osmotic pressure are called as isotonic solutions. Example is very important, you should be knowing. RBC, red blood cells, is isotonic with 0.9% of NaCl solution, which is called normal saline. Okay, so 0.9% NaCl solution and the RBC have the same osmotic pressure. It is used in injections instead of distilled water, so this is not required. Next, the solution whose osmotic pressure is higher than that of the given solution is called as hypertonic solution. Here example, when RBC is placed in a seawater, so if you place the RBC in the seawater, where seawater concentration is very high, water passes out of the cell due to the osmosis and the cell shrinks. Hypertonic. So seawater is having more pressure, more concentrated. Okay. Next, if you see hypotonic, the solution whose osmotic pressure is higher than that of the, it is lower. Okay, here a small mistake. The solution whose osmotic pressure is lower than that of the given solution is called as hypotonic. Okay, hypotonic. Now example, when RBC is placed in a hypotonic solution, they swell. Okay. Next we have what is edema and what is the cause for the movement of water from soil to plants, and preservation of meats by salting and of fruits by adding sugar protects against bacterial action explained. So these are some of the I can say applications of osmosis. So what is edema? So what happens when people intake a lot of salt, okay, or salty food, experience water retention in the tissue. So now see, when you are taking a lot of salt, okay, so your cells are now, I can say, more concentrated, right, more concentrated. So water will flow from outside to inside your cell. So what will happen, the cell will be retained in the inside the cells and in the intercellular spaces because of osmosis. Now this results in puffiness and swelling called as edema. Okay. Next, what is the cause of the movement of water from the soil to the plants? Again the same thing, the soil have more water, so they can move from higher like lower concentration to higher concentration, osmosis. Next, preservation of meat and salt by, so when you add salt and sweet or anything to the meat or to the fruits, so what happens actually, what will happen, water from the meat will flow out, right, from the higher concentration to the lower concentration. So now when there is, through the process of osmosis, a bacterium on salted meat or candied fruit loses water and shrivels and dies. Okay, so whenever a bacteria comes to attack that meat or want to spoil that meat, because of the salt solution, the water will move out from the bacteria's body to the meat. Okay, so what will happen, the bacteria will shrivel and will die. Okay, very, very common things that we observe in our daily life. Next is, what is osmotic pressure, give equation, and what is reverse osmosis. So external pressure applied on the concentrated side to stop the osmosis is called as osmotic pressure. What is equation? Equation for this one is pi is equal to C into R into T, right? Pi is equal to C into R into T. C is concentration, R is gas constant, and T is temperature. Next, when a pressure more than the osmotic pressure is applied on the concentrated side, then what will happen? Water will flow out, and that will cause to you reverse osmosis. Okay. Next, explain the desalination of water by reverse osmosis and name the semi-permeable membrane used in this process. Yes, so when you add more water, so reverse osmosis takes place and desalination of water takes place, and the semi-permeable membrane that is used in this process is called cellulose acetate. Okay, so please remember this one. So now see, reverse osmosis is used in the desalination of seawater. When a pressure more than the osmotic pressure is applied to the seawater, pure water is squeezed out to the seawater through the semi-permeable membrane. You can see the diagram here. Okay, so osmosis was happening from this direction to this direction. Now when you add a pressure greater than the osmotic pressure, water will start flowing in this direction. Okay, and pure water can be obtained here. That is called as reverse osmosis. Okay. Next, why osmotic pressure is used to calculate the molecular mass of polymer? This is very important question. Many of the papers have been asking this question. That is because of it uses molarity instead of molality, the first thing. Next one is, it can be measured even at a room temperature. Okay, the osmotic pressure can be measured at room temperature, and the osmotic pressure value is very large as compared to the other colligative properties. Okay, so we have big values which can be calculated easily. So these are the three factors, so you should remember them. Next we have what is abnormal molar mass and what is Van't Hoff factor. What is the conclusion drawn when Van't Hoff factor of a solution? Okay, so one second. Okay, so what is abnormal molar mass? So the molar mass determined by the colligative properties is found to be lower or higher than the expected normal molecular mass. Such a mass is called as abnormal molecular mass. Then What is Van 't Hoff factor? So Van 't Hoff factor is the ratio of normal molar mass to the abnormal molar mass. You can see the different equations of Van 't Hoff factor. Any one is fine. Okay. Next, this one is something incomplete question. Okay, so that's all students in case of solutions chapter. We have seen so many questions, and these questions can be mixed and can be asked in 2-marker and in the 3-marker questions. But I hope if you do these many questions, then definitely you will be able to attempt all the questions that is asked in your exam. Okay, now we will be moving towards the next chapter, that is chemical kinetics. First question, 2-marker and 3-marker I have segregated here. So what is an average rate and what is an instantaneous rate? So average rate is calculated in a certain interval of time. Instantaneous rate is calculated at that particular point of time. Okay, so very small interval is instantaneous, and for a long duration or a long interval is called as average. Okay. Next I have what is the rate law or rate expression? Define rate constant, velocity constant, or specific reaction rate. Okay, so this all thing stands for one word, that is rate constant. What is rate law, rate expression? It is an expression which relates the rate to the concentration of the reactants. Okay, so you can see rate law is the expression which reaction rate is given in terms of the molar concentration of the reactants, with each term raised to the power which may or may not be equal to their stoichiometric coefficients. Okay. Next, what is rate constant? Rate constant of a reaction is equal to the rate of the reaction when the molar concentration of each reactant is taken as unity. Okay, so we have this one, right? Okay, so if this concentration becomes 1, okay, so whatever is rate, that is rate constant. So rate constant is that rate when the concentration of all the reactants is taken as 1. Next we have what is 0th order reaction. Give an example. So 0th order reaction is those reaction which is independent of the concentration, right? The rate of the reaction is independent of the concentration is called as 0th order reaction, and here I have 2 examples, decomposition of ammonia and we have thermal decomposition of hydrogen iodide. Okay, decomposition of ammonia and thermal decomposition of hydrogen iodide. You also have photochemical combination of hydrogen and chlorine on the surface of water. So these any examples you should remember. These all values don't have to remember, only 3 examples, please remember that. Next, what is first order reaction and give an example? Same thing, the rate of the reaction is directly proportional to the concentration of the reactants. What are the orders? Example, radioactive decay, decomposition of N2O5, decomposition of H2O2. Okay. Next, define half-life of a reaction and okay, or how many times does the half-life of 0th order reaction increase if the initial concentration of the reactants is doubled. This is very simple. Half-life of a reaction is that time where time required for the reactant to reduce to half of its initial concentration, right? And if you remember, for 0th order reaction, if I write 0th order reaction, T half value is what? A0 by 2K, right? So if the concentration is doubled, then T half will also be doubled. Okay, so that is option number B. Next, what happens to half-life time of a first order reaction when the temperature is increased? Give reason. Okay, so here you can see T half. What's the formula of T half? We have 0.693 by K. When you increase the temperature, K will also increase. If K will increase, T half will decrease. Okay, this is a very good question. Next, what happens to the half-life for a first order reaction if the initial concentration of the reactant is increased? See, for half-life of a first order reaction, it is independent of the initial concentration. So that way it will be remaining constant. It does not depend on the concentration. Next, what is pseudo first order reaction? Give an example. So pseudo first order reaction, higher order reactions can be converted into first order by when one of the reactant is present in excess. Examples are 2, you just have to remember the name: acid hydrolysis of esters and inversion of sugar. Okay, no need of any explanation or anything, you just need to know these 2 examples. Okay. Next, we will move to what is the effect of temperature on the rate of the reaction. Then define temperature coefficient of a reaction. Very, very important question. So effect of temperature you can say easily, when the temperature increases, rate increases, or for every 10 degree rise in temperature, the rate increases by 2 times, right? Okay, what is the formula for temperature coefficient? Rate constant at temp T plus 10 divided by rate constant at that particular temperature, which is approximately equal to 2. Okay. Okay. Next, how do you calculate the activation energy from the Arrhenius equation by graphical method? So you can have this one. So we have this equation, right? Ln K is equal to A into e to the power of minus Ea by RT. Now if I take log of that, I will get this equation. Now if I plot a graph for log K versus 1 by T, then I will get this value, and the slope of this one is minus Ea by 2.303. So by calculating the slope from the graph, the energy of the activation can be calculated. Okay, so this question is also little non-conventional question, but can be asked. Next, explain the effect of catalyst on the rate of a reaction. So what happens when you use a catalyst? Rate of reaction increases because it decreases the activation energy. Okay, and you have to draw this diagram. This is very important diagram. Okay, so when this is the rate constant at this is the activation energy without catalyst. This is the activation energy with catalyst. So activation energy decreases, so definitely rate will increase. Next, what is the main criteria for effective collisions of, this is a question that has been repeated in many of the pre-board papers. So criteria for effective collision is sufficient energy. Okay, you can write down sufficient energy and proper orientation of the molecules. Okay. Next, what is a collision frequency, and give a drawback of simple collision theory. So collision frequency, number of collisions per unit volume per second. Okay, number of collisions per second per unit volume of a reaction mixture. Next, what is the drawback of collision theory? It considers reactants as hard spheres and ignore their original structures. Okay. Next, we will go to 3-marker questions. So name the factors affecting the rate of a reaction, or on which factors the rate of a reaction depends. So it depends on concentration, temperature, presence of catalyst. Okay, these are the 3 important factors you should be writing: temperature, concentration and catalyst. Other is also there, presence of light, nature of the reactants, but I feel these are the best factors that you can remember. Next, define the molecularity of a reaction. What is an elementary reaction? Define order of a reaction. So molecularity is the number of species reacting in an elementary step. What is elementary reaction? Reaction that occurs in one step. Order of a reaction, it is the sum of the power of the reactants in the rate expression. Okay, so you can see, suppose L and M is there, so order will be L plus M. Okay. Next, what is the slowest step in a complex reaction called as? It is called as rate determining step. Which step of the reaction mechanism decides the order? It is the slowest step or the rate determining step. For what type of reactants is molecularity and order the same? For elementary reactions, the molecularity and order will be same. Okay, so it is rate determining step, slowest step. Order and molecularity are same in the slowest step of the complex reactions. Okay, or you can write for the elementary reactions. Okay, difference between order and molecularity, this is also very important question. Any 3 points you can write down, like experimentally determined, theoretically determined. Their definitions you can write. Order can be 0, molecularity cannot be 0, it cannot be a fraction, it has to be a whole number. Okay. Next, derive an expression for the integrated rate equation for a 0th order reaction. So this is very common question. Okay, so you have this derivation. So first you have to take rate is equal to, like I can write like this: rate is proportional to r to the power of 0, rate is equal to k into r. So r to the power of 0 is 1, so I can write rate is equal to k. Also for a 0th order reaction, I can write rate is equal to minus dr by dt. Then I can equate these two, minus dr by dt is equal to k. Then you take integration on both sides, you will get an integration constant. Find out the value of integration constant, substitute it, and then find the value of the integrated rate equation. Similarly, you will have for half-life of a zeroth order reaction. Okay, so here this is the integrated rate equation for zeroth order. Now for half-life, this R will become R naught by 2. So I can write here R naught minus R naught by 2 divided by T half. Okay, so if I solve this, I will get R naught by 2K. Okay, direct simple formula substitution based question. Next we have next is derive the integrated rate law for the first order reaction. Same question. This is also very popular question. First of all, you have to write R is proportional to K into R and rate is equal to minus dr by dt. Now you can equate these two equations. After that, take rearrange the equation. You take this R this side, T this side, then integrate it. You will get this one. Here you have to find the value of I. To find the value of I, what you can do, you can take T equal to 0, R is equal to R0. Okay, then just substitute it. You will get here. This will be the final equation. After that, you can convert it into log value. Okay. Next. Okay, half-life derivation similar to zeroth order. So this is my equation for first order. I can put R0 as R0 by 2 here. R is equal to R naught by 2 during half-life. If I substitute this one, I will get 0.693 by K. Okay. Next, derive the integrated rate equation for the first order gas phase reaction. Okay, this is important question. Okay, so let us derive this one. See, I will derive this for you. We'll write it. So if I have a reaction A gives B plus C. Okay, so let the initial pressure is Pi. This will be 0. This will be 0. At time is equal to 0. At some time equal to T, suppose X amount has reacted. Here X amount will form. Here X amount will form. Now the total pressure here is what? I can write Pi minus X plus X plus X. Right. So I can write this one as Pi plus X is equal to P total. So what is the value of X here? X I can write it as Pt minus Pi, right? Then what is the pressure of A at time T? Okay, so that was what? Pi minus X. Now in place of X I can substitute this one. So Pi minus Pt minus Pi. So if I calculate this, I will get 2 Pi minus Pt. Okay, so I got, now I can write down K is equal to what? 2.303 by T log of initial pressure of A by final pressure of A. So I can write 2.303 by T log of initial pressure is Pi and final pressure I calculated is 2 Pi minus P total. Okay, this will give you K value. Next question, the temperature coefficient of a reaction is 2. How many times the rate of the reaction is increased when the temperature changes from 300 to 350? So you have increased by 5 times, like 5, I can say how many 10 degree are there? 300 to 310, 320, 330, 40 and 50. Right? So 1, 2, 3, 4, 5. So 2 to the power of 5, that is 32 times it will increase. Okay. Next, what is Arrhenius equation and state as to what the symbol stands for. So Arrhenius equation, all of you know, K is equal to A into e to the power of minus EA by RT. K is rate constant, A is frequency factor, E is your activation energy, R is gas constant and T is temperature. Next, what is the energy of activation? So what is activation energy? Next, oxygen is available in air, yet fuels do not burn spontaneously at room temperature. Why? What is threshold energy? So reactants are there. Reactants require a certain amount of energy to get converted into product. That certain amount of energy that reactants require to get converted into products is called as your threshold energy. Now the energy that is required for the reactants to reach to the threshold energy is called as your activation energy. Let me just show you in the form of a diagram. See. So this is your reactants. When reach this much energy, they can get converted to product. So this is called threshold energy. Now reactant at this are in this point. To reach to the threshold energy, whatever energy is required to be provided, that is called as your activation energy. Okay, so you can see here the minimum excess energy acquired by the reactants upon collision to form a activated complex is called as your activation energy. Next, what is this one? Why is it not catching? Because the activation energy for this reaction is very high and is not possible at room temperature. Okay, next, the minimum energy that the reacting molecules should possess in order to form products. This energy to form products, what energy they require, that is your threshold energy. Okay, next, explain the Arrhenius theory of activated complex by using potential energy diagram. This is very important question. Okay, so what does Arrhenius theory says to you? See, according to Arrhenius theory, the reaction can take place only when the reactant molecules collide to form an unstable complex. It exists for a very short time and breaks up to form product. So Arrhenius theory says that the reactants do not directly get converted into product. Reactants get converted to some activated complex, and from that activated complex product formation takes place. Okay, so here you can see in the formation or in the reaction of Hi, H2 and I2, we get an intermediate complex, that is a structure is formed like this, and this structure breaks to give you the products. Now what is the diagram? How can we show it? So this is what reactants are there, products are there, but it goes through the activated complex, does not directly gets converted into product. Okay, so that is Arrhenius theory. This is very important question. It has been asked also in some exam. Next, using the energy distribution curve, show the temperature dependence of the reaction. Explain the effect of temperature on the rate of the reaction. So here you have to do Boltzmann distribution curve. So you can see, as you increase the temperature, number of particles having energy more than the threshold energy increases. So that is why more number of particles can take place in the reaction, can participate in the reaction. So the rate of the reaction will increase. Okay, how can we write it? See. So we can write from here, just can draw the diagram and write down from here. Okay, increasing the temperature of the substance increases the fraction of molecules which collide with energies greater than the activation energy. Clear from the diagram that in this area, this one, okay, here more number of particles are having energy greater than or equal to the activation energy, and that is why when you increase the temperature, the rate of the reaction increases. Okay. Next, what is the effect of catalyst on Gibbs free energy? No effect. Among spontaneous and non-spontaneous reaction, which one is affected by catalyst? And what is the effect of catalyst on the equilibrium state and equilibrium constant in a reverse reaction? Here no effect, here also no effect. Okay, so here does not alter the Gibbs free energy, does not change the equilibrium constant. It catalyzes only spontaneous reaction and does not catalyze the non-spontaneous reaction. Okay, so that's all students in the chemical kinetics chapter. Next chapter we'll be doing is your electrochemistry. Hello students, so now let's continue with the chapter electrochemistry. Okay, so in this I'll be telling you, so you will be getting, so 1 second, yes, so we will be getting 2 3-marker questions. Okay, 2 TW, so I'm telling number 2 3-marker questions from this chapter, and yes, I'll be telling you all the important questions that is there. So the first question is, state Faraday's law of electrolysis, mention the factors on which the products of electrolysis depends. So now here I'll be telling you the answer for this question. So let me first tell you what is about the important of this question. This first part, okay, is very important. You must learn both the first law and the second law of Faraday's. Okay, so here I will add a tip that also remember, also study first law, okay, and equation. Okay, you have to revise this one as well. Okay, so I have added some question, and I'll also be giving you what else you have to study. So Faraday's second law, you know, then you pass the same amount of current, the mass deposited at 2 different cathodes will be equal to their equivalent weights. The ratio will be equal to the ratio of their equivalent weights. Now here what we have, here we have M1 by M2 is equal to E1 by E2. Clear? That is what you have to write down. Now the factors on which the products of electrolysis depends. The products of electrolysis depends on nature of the electrolyte, nature of the electrode and over voltage. Okay, nature of the electrolyte, nature of the electrode and over voltage. There are other two factors also. I think I can remember these three factors easily, so I have given these three factors. Apart from this, you should also study about the products of electrolysis for molten NaCl, okay, and for aqueous NaCl. Okay, these two things also you should remember. Okay, let's move to the next question. Direct measurement of conductivity of ionic solutions by Wheatstone bridge is not possible. Give reasons and suggest a remedy to resolve it. Now see, this question has not been asked in the previous year, but this year in the model test paper and even in the pre-board papers these questions have been asked. So make sure, I think that this question is very important. Earlier if you see the analysis of previous year, this question is not that important, but yes, now in the current trend I can say this is a new question that has come to the market. Okay, so please, I will mark this question as also very, very important. Now what you have to see here, so first problem is with the direct current. Okay, direct current can change the composition, and the second one is you cannot connect the wires to the electrolyte because it is a liquid. How the problem is solved? By using alternating current, and for the electrolyte we use a conductivity cell where we pour the electrolyte and the wires are connected to the conductivity cell. Okay, so this is important question. Next, explain the construction of SHE and explain the working principle, and platinum platinized is used in the construction, give reason. So this first part, okay, this first part is very, very important. Many question papers have been asking these questions repeatedly over years. So yes, this is very important question, the construction. So here you should be writing the construction and drawing the diagram. So I can see you what is happening in the construction. You have a platinized platinum foil. That platinized foil is connected with a platinum wire. Platinum wire is connected to mercury wire. Mercury wire is connected to the copper wire. Okay, so you just imagine, just see the diagram. You don't have to remember anything. You have a platinized platinum, here you have platinum, here you have mercury, here you have copper. Okay, so the standard hydrogen electrode consists of a platinum foil coated with finely divided platinum. The platinum foil is connected with platinum wire with mercury. Now a copper wire is connected from the mercury for the external circuit. The platinum foil is dipped in 1 HCl solution as shown in the figure. So this is the figure that you should be drawing. You should be knowing the figure, all the levelings you should be drawing properly. Okay, this is very important question. Okay, I am not highlighting it because I think it is decreasing the legibility of the question, so I will underline it. Okay, this is very, very important question. Working principle of SHE, not that important. Okay, not that important. Now why platinum platinized is used? To increase the surface area. Working principle I have given here. So when you give hydrogen, you put hydrogen through this inlet continuously, then what happens? The hydrogen gets absorbed here. It is in contact with 1 molar HCl where it undergoes this reduction reaction. Okay, so yes, that is the thing. Okay, and you should know what is the potential of this SHE. It is 0 volt. Okay, it is considered to be 0 volt. That also you should be knowing. Next we'll go to next question. This is also very, very important question. That is your hydrogen oxygen fuel cell. Draw a neat and level diagram for H2O2 fuel cell and write the cathodic and anodic reaction. Very important question. Okay, I am writing VVI, means you must study those questions. Okay, so here if I see first of all diagram, you have anode, you have cathode. On the anode side you will give hydrogen, on the cathode side you have oxygen. Then you have aqueous NaOH as the electrolyte. Okay, this is the construction. Next what happens here? Neat and level diagram. So you can see oxygen, that is cathode. Okay, O2 plus 2 H2O plus 4 electron gives 4 OH minus. Then H2 plus 4 OH minus gives 4 H2O plus 4 electrons. Then the overall reaction you can write down here. Okay, next we'll move to question number 60. Write the anodic and cathodic reactions of dry cell and explain the role of the produced ammonia. So this is not that important question, so I will just mark as important, IM, not very important. Okay, this type of some alternative year or once in 2-3 years these questions have been asked. So yes, you can remember dry cell. Zinc is used as an anode. At the cathode what happens? MnO2 undergoes reduction to form MnOOH plus NH3. Now the ammonia that is produced here forms a complex with Zn2 plus to give you ZnNH3 whole for 2 plus. Okay, next we'll do some more questions on dry cell, that what is the anode and cathode, what is the electrolyte, and what is the voltage produced by the dry cell. Okay, so this also I can mark as important question but not very important. Okay, so here you can see zinc anode is used, cathode graphite rod surrounded by MnO2 and C, electrolyte is NH4Cl and ZnCl2, potential or the voltage is 1.5 volt. This things can be asked in the MCQs as well, so you should be remembering these important terms. Now we'll move to the next question. Plot a graph between, okay, so yes, now this first part again, yes, this question is also, sorry, okay, 1 second. Okay, so this question is also very important question. Plot a graph of molar conductivity versus concentration for strong and weak electrolyte in the solution. So I have a graph like this. Okay, so you have lambda m and root over of C. So for strong electrolyte you have to draw the graph like this. For weak electrolyte the graph is like this. This is for strong electrolyte, this is for weak electrolyte. Okay, so that's all. Next, for strong electrolyte, write the equation that represents the variation of molar conductivity with dilution. So what I have, this equation is also called as d by Huckel equation. Okay, so in the question if it is asked in the term that write the d by Huckel equation, then also you should be able to write lambda m is equal to lambda naught m minus a root C. Okay, that is the equation. Next, we'll go to explain the determination of standard reduction potential value of zinc electrode by using standard hydrogen electrode as a reference electrode. Now, this question is also a new question in the market. Okay, not very important, but yes, I can just write it down as important. Okay, so yes. So, or I don't think this question is that important. I will write it as optional. Okay, so if you feel like if you have time, then go for this question, or if you do not have time, you can just leave this question. Okay, so but the answer is very simple. I'll be telling you in 3 points. I'll tell the answer. You have to write as it is in the exam and come. So what is the first thing you have to consider? Consider SHE as reference electrode. Okay, I'm writing in short, you have to write the full words. The zinc rod, okay, here zinc can also be asked, or zinc or copper can also be asked, like either zinc or copper. So the zinc rod is coupled with SHE. Now the third one, what I can write? Zinc rod is coupled with SHE. After that, what happens? The potential difference, okay, the potential difference is measured, the potential difference is measured by potentiometer, as for zinc it is minus 0.76 volt. So the electrode potential of zinc 2 plus 2, so zinc is minus 0.76 volt. Okay, so here what I can write? So now see, if this is there, if this copper, if it is asked with copper, then this value, E naught value will be 0.34 volt. Okay, then next question. Explain the rusting of iron is an electrochemical phenomenon. Yes, this question I can say is an important question. Okay, very important question. The rusting of the iron is an electrochemical phenomenon. Very important question. So you should read this question. So here what happens? any spot on the metal can act as a anode. Okay, so at anode what will happen? Oxidation will take place. So Fe will lose electrons to give you Fe2 plus and 4 electrons. Now these electrons will move to another spot of the metal where it will reduce oxygen in the presence of H plus. So these 4 electrons have reduced oxygen in the presence of H plus to give you water. Now this Fe2 plus which is produced is further oxidized by the atmospheric oxygen to ferric ions which come out as rust in the form of hydrated ferric oxide. Okay, so that is the answer for this question. Next, what is the effect of dilution on conductivity, effect of dilution on molar conductivity? So this is also a very important question. Yes, this is, I'll mark it as very important. This part especially, this is very important. Okay, so what you should remember here, conductivity decreases on dilution. Okay, why? Because conductivity is the conductance, conductivity is the conductance per unit volume. Okay, is the conductance for number of ions per unit volume. Okay, so if, or you can just mention by per unit volume. Okay, so that is why when you decrease the concentration, conductivity decreases. But here what I can write, molar conductivity increases. Okay, on dilution molar conductivity increases. Now what happens to molar conductivity when 1 mole of KCl dissolved in 1 liter is diluted to 5 liters? So yes, if it is diluted to 5 liters, definitely molar conductivity will increase. Okay, next is how to prevent corrosion. So yes, this is also like normal question, not very important, but yes, this is a general question you should be knowing. You can do painting. Okay, or next thing is galvanization. Next thing is sacrificial protection. Clear? Now next part is PB lead cell reactions. Okay, so what is there in the lead cell reaction? So here you can see lead, that is PB, is undergoing oxidation to give you PbSO4, and PbO2 is undergoing reduction to give you PbSO4. Okay, so these are the, this lead cell reaction is also very important, so please remember this one. Okay, tricell is not that important, but yes, lead cell is very important. Next we have Kohlrausch's law. Yes, Kohlrausch's law is again very important question. So you should be knowing Kohlrausch's law, direct statement. So at infinite dilution, the molar conductivity of an electrolyte is the contribution of its anions and cations. Okay, statement you can write down. What is its application? It is used to calculate the molar conductivity of weak electrolytes. Okay, next we'll move to the next chapter, that is D and F block elements. Okay, so here also some important questions I have taken. Catalytic property of transition elements, very important question, do not miss, easy question, easily you can get. So let me tell you from here what type of questions we will get. See, in the 2 marker questions there will be 1 question either from transition metals or from coordination compounds. So you will get 2 marker, okay, and 3 marker. Okay, so this 2 marker is optional, but yes, 3 marker, at least 2 to 3 questions you will get. So first question is that explain the catalytic properties of the transition metal. So what is the reason catalytic property? You can write down any 3 points. Okay, variable oxidation state, large surface area for adsorption, presence of incompletely filled d orbitals, formation of intermediate compounds. Okay, here are the 4 points. Example you can write down, V2O5 is used as a catalyst and in the manufacture of contact process. So yes, I think the most important points are variable oxidation states, presence of incompletely filled d orbitals, formation of intermediate compounds. Okay, next we'll move to what is lanthanide contraction. Okay, write the cause for lanthanide contraction and the consequences of lanthanide contraction. This is again very important question. Okay, so what we have to do here, this is very important question, so please do not miss this question, very important. So here you can know what is lanthanide contraction, steady decrease in the size of the ions across the period. Cause of lanthanide contraction, poor shielding effect of 4f orbitals. Any two consequences, or you can remember that is size of zirconium and hafnium is equal, basicity is basicity decreases along the period, and one more consequence also I'll tell you, so that if it comes as a 3-marker question you can write down directly. So you can write down here one more, separation of elements is different. Separation of elements becomes difficult. Okay, so 3 points. If directly on consequences a 3-marker question comes, then also you can write down the answer. Okay, next we have study of actinoids is very difficult, give 3 reasons. So here we have actinoids have shorter half-life, they are produced in nanograms, and they are radioactive. Okay, so this is also, I'll write important but not very important. Next, preparation of potassium dichromate, this is a very important question. Okay, so you have to write here VVI, definitely must study this one. Okay, so you can just write down, remember, I know this is difficult to memorize, but yes, please rewrite it, practice it again and again, and memorize these reactions. Balancing of equations should be done. Okay, so yes, so remember with balanced, remember with balancing. Okay, means you know how you can do balancing in the exam, but yes, some idea you should have, so that you don't waste time in balancing this reaction. Next question is potassium permanganate manufacture. Okay, this is also again very important question. K2Cr2O7 and KMnO4 are asked, I can say, alternatively. Okay, so yes, first here MnO2 is converted to K2MnO4, K2MnO4 is converted to KMnO4. Okay, so yes, this is also important question. Next, why Ce shows one second, yes, why Ce shows a +4 oxidation state. Yes, this is important question again. So, and next question, what is the oxidation state, highest oxidation state shown by the actinoids, or name the elements that shows the highest oxidation state among the actinoids. Yes, so this question is also very repeated. This part is important question. Okay, so let us see the answer for this one. So Ce shows +4 oxidation state because of its stable configuration of 4F0. And what is the highest oxidation state shown by actinoids? +7. Which elements show them? Np, that is neptunium, and Pu. Okay, so these are the two things that you should remember, Np and Pu. Even symbols, if you remember, that is also fine. Next, differences between lanthanoids and actinoids. So this is again, I can say, a optional question. Okay, not very important, but yes, you can remember 2 points. Very basic, you can write down here electrons enters to the 4F, here electrons enters to the 5F. Here all are radioactive, here except promethium, they all are non-radioactive. Then you can write they are less basic, more basic. Okay, they have less shielding effect, here they have more shielding effect. So these are the things that you can write down. Next we have is what is the composition of mic metal, give its use. Yes, this is also very a new question and important question that is there in this year exams. So mic metal, you can know it is lanthanoid 95%, iron 5%, traces of sulfur, carbon, calcium and aluminium. What is its use? Use in the magnesium based alloys to produce bullet, shells and lighter flint. Okay, next is, yes, question number 78, to calculate the magnetic moment. Okay, so this is important question. I'll be telling you one how to find out, others you can do it as the given values. Okay, so what you have to do, mu formula you have to write root over of n into n plus 2, right? So for example, as here it will come 0, I'll take Ti3 plus, scandium, titanium. Titanium electronic configuration is 3d2 4s2. Titanium 3 plus is 3d1. So I have root over of 1 into 1 plus 2, that is root over of 3, that is 1.7. Okay, so you will be getting the answer here for this one, 1.7 bm. Okay, units should be written. Clear? Next, like this you can do for all the elements. Okay. Next, on what ground can you say that scandium is a transition element but zinc is not? So this is a question from the definition of transition elements. So what are transition elements? Transition elements are those, so this is also I can say important question. Okay, transition elements are those elements which have unpaired or partially filled, I can write partially filled d orbitals, okay, either in ground state or in common oxidation state. Okay, so now if you see scandium, okay, scandium has scandium electronic configuration, if you see it is 4s2 3d1, so it has unpaired electron. But if you see zinc has 3d10 4s2. Even zinc 2 plus, that is in its common oxidation state, is also 3d10, so it doesn't have unpaired electrons at all. So that is why zinc is not a transition element. Now silver atom has completely filled d orbital in its ground state. How can you say that it is a transition element? So if you remember, silver in its Ag plus state, okay, so sorry, silver can have Ag2 plus state as well, where it has 4d9 configuration. Okay, so in this 4d9 configuration, because it has 4d9 configuration, it is a transition element. Okay, next, okay, so here I'll clean the answer so that you can find the exact answer how to be written in the exam. Okay, so yes, next we have why Cr2 plus is reducing and Mn3 plus is oxidizing when both have D4 configuration. Yes, this can be a very good question, important but not very important. Okay, so now if you see Cr2 plus, I'll write Cr2 plus, okay, its electronic configuration is 3d3, right, and Mn3 plus, its electronic configuration is 3d4. Now see, Mn3 plus wants to move to Mn2 plus. Why? Because it will get a stable electronic configuration. So now what is happening? It is undergoing reduction. It wants to undergo reduction, so it will behave as an oxidizing agent. Okay. Now Cr2 plus is very stable in 3D configuration due to T2G configuration. Okay. Sorry, one second. Cr electronic configuration is 3d5 4s1. Cr2 plus is, here we will remove 3d4. Okay, yes, so Cr3 plus, I have made a small mistake here. Okay, so let us first talk about manganese, then we'll talk about chromium. See, manganese is having +3 oxidation state where 3d4 configuration is there. If it becomes Mn+2 where it has 3d5 configuration, it will have a stable configuration, it will undergo reduction and it will behave as an oxidizing agent. Now if you talk about Cr2 plus, okay, Cr2 plus has the electronic configuration of 3d4, and if I have Cr3 plus, it is 3d3. Okay, now 3d3 is again a stable configuration because T2G3 configuration. So now if you see here, +2 to +3, it wants to undergo oxidation, right, it wants to undergo oxidation, so it will behave as a reducing agent. Clear? Next, why is the highest oxidation state of a metal exhibited by its oxide or fluoride only? So I will be showing you the answers how it is to be written. So yes, first one I have already explained. So oxygen and fluorine are highly electronegative and have a very small size, so they can stabilize the higher oxidation states. Next, which is a stronger reducing agent between Cr2 plus and Fe2 plus? Stronger reducing, they will reduce others, itself it will get oxidized. So if it is oxidizing, Cr will get converted to Cr3 plus, Fe will get converted to Fe3 plus. Now Fe3 plus has D2,5 configuration, Cr3 plus has T2G3 configuration. This one is more stable because its energy is lesser. This one is more stable, so that is why Cr2 plus is a stronger reducing agents. Okay. Clear? So these all questions I will mark as important, but yes, again, not very, very important. Yes, next, write the structure of chromate and dichromate ion. Okay, so chromate ion structure, you know, CrO4 2 minus. So we can draw like this. Okay, tetrahedral structure, CrO4 2 minus, and this is dichromate is Cr2O7 2 minus. Okay, so we have like this structure. I can draw like this. Just a minute. Yes, 1 2 3 4 5 6 7 Cr2O7 2 minus tetrahedral structure. Okay, this is not optional question, you can write it as optional. Let us see the next question here. The element of the first transition series that has the highest second ionization enthalpy. So the first element which has the the element of the first transition series with second highest ionization enthalpy is copper. Next, element of the first transition series with highest number of oxidation state is manganese. The element of the first transition series that has the lowest enthalpy of atomization is your zinc. Okay, okay, here I want to discuss some questions that I think I have missed it. Not missed, actually I have left space for that. Just a minute. Yes, so I have discussed here what is catalytic property, right? Apart from this, what other properties you should prepare? See, you should also prepare about why they form complex compounds. Okay, why they form complex compounds, why they form what are interstitial compounds. Okay, what are interstitial compounds, and next you should be drawing about the why they show color, why the D block elements are colored compounds. Okay, so these all definitions also you should be knowing. So for example, if I want to talk about complex formation, so complex formation, why do they do complex formation? Because of, I can say, availability of d orbitals. Okay, right, variable oxidation states, right? Next, what are interstitial compounds? So definition you all know, you can just watch, but I'm telling you the topics, so please mention, read these topics as well as. Okay, fine. Now we will go to the next chapter, that is yes, I was discussing this question, right? Okay, next chapter is your coordination compounds. So state the postulates of Werner's theory. Very, very important question. Okay, here I will mark it as very, very important. So please learn it. This can also be asked in a different way, that is difference between primary valency, okay, and secondary valency. Any of the question can be asked. Okay, so most probably it will asked in the form of Werner's theory. So you can write down the postulates of Werner's theory, that it has two types of valency. A coordination compound has two types of valency, primary and secondary valency. Primary valencies are the normally ionizable valencies and are satisfied by negative ions. Secondary valencies are non-ionizable and these are satisfied by neutral or negative molecules. Secondary valency tells you about the coordination number of a metal. Okay, next, the secondary valency also gives you the geometry or the spatial arrangement of the ligands in the metal. Okay, next we have the applications. This can be also asked as a question. What are the applications of coordination compounds? So here are some detailed applications that you should remember. So I have given in points. This is not in the form of question. So hardness of water is removed by EDTA. Extraction or process of gold and silver is using your coordination complex. Purification of metals can be done by using NiCO4. Then the pigment responsible for photosynthesis is chlorophyll. Coordination compound of magnesium. Then hemoglobin has iron and vitamin B12 has cobalt, and it is called as cyanocobalamin. So these all things you are there in the application which you should remember. Next, draw the geometrical isomers of CONH3 whole 3 NO2 whole 3 and PTNH3 whole 2 Cl2. This is also very, very important question. Okay, so if you see here, CONH3 whole 3, so this is Ma3B3. So here you will get facial and meridional isomers. Okay, so let us see. You have like this CO coordination number is 6, right? So if I take any one face, okay, like this is one face, okay, so here I have to put the same ligands. So CO, NH3, 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 sorry, not here, this one. Yes, so NH3, NH3 and NH3, here I can put NO2, NO2 and NO2. Okay, this is what? This is facial. Meridonial, anything apart from this you can take, you will get meridonial. Okay, so I can take like NH3 here, NH3 here, NH3 here and NO2, NO2 and NO2. Okay, next here MA2B2 type, so you will get cis and trans. So this is very easy. You have PT, NH3, NH3, I am just writing in short, Cl, Cl. This is your trans form. Okay, and how will you get the cis form? Cis form will be NH3, NH3 and we have Cl and Cl. Okay, so this is your geometrical isomers. Next, define ambidentate ligands. Yes, these are also very important question. So you can see here, sorry, definition. Ambidentate ligands are those ligands which have two donor sites but any one will react at one particular time. NO2 minus and Cn minus examples. Then heterolytic complex which have different types of ligands. Okay, different types of ligands. So here you should also prepare for homolytic complex. Okay. Next, what are chelating ligands? Chelating or chelating, however you pronounce it. So these are the ligands which form a cyclic structure. Okay, example I can write ethane, En, EDTA, okay, C2O4, 2 minus. So these all are the examples of chelating ligands. Okay. Next, we'll move to synergic bond. So I will not say this is very important, but yes, this is important where we have to explain the metal carbonyl bonding. Okay, so first of all, what happens? There is a sigma bond between the ligand, that is carbon and metal. Okay, there is a back bonding from the filled d orbitals of metal to the empty pi star anti-bonding orbital of the carbon. Okay, so that you can see here, that is explained, and these have been written in the form of points. So due to this, what is the consequence? So this MC bond is very strong because of this double bond. Okay. Next, we have limitations of CFT and VVT. I think this question can be an optional question. Not many years it has been asked, some years it has been asked. So just remember two limitations of both. So these are the limitations of VVT, like for example, does not tell anything about the magnetic data, does not tell anything about the color of the compounds, okay, does not tell anything about the stability of the compounds. Okay, so you can write any 3 points here. Next, limitations of CFT. So it does not consider ligands as consider ligand as point charges, that is one limitation, and does not take into account the covalent nature of the metal ligand bond. Okay, it considers them only as ionic, whereas their actually covalent nature is also there. So these are the two limitations. Okay. Next, yes, this is very important question. D orbital splitting diagram. Please, all the leveling should be done correctly and the diagram should be done correctly. I am not explaining, this is already there. Similarly, for tetrahedral, this is also very important. Okay. Next, we'll move to draw the geometrical and optical isomers of. So isomer drawing, COCl2 En2. So this is like this. If I draw the geometrical isomers, okay, so this is your trans form. Okay, now you can have the cis form as well. Okay, you can draw the mirror image. Okay, now what will happen? This one cannot overlap on this one, right? So these are the optical, so this is cis. So cis isomer will have an optical isomers. Now next one, CONH3 whole Cl En2 plus. This is also similar to this one only. You can draw like this. CO, En is there, En is there, NH3 is there, and Cl is there. Okay, this is your trans form. the cis form will be, you have NH3, Cl, En and En. Okay, the next, the mirror image of this one you can do, so it will also have 3 isomers. Next, CONH3Cl2En. If I draw this compound, you have like this, see, this is having 3 isomers, this is also having 3 isomers, 2 geometrical, 1 optical. But if you see this compound, it is like this, NH3, I can draw 2 NH3 opposite to each other, okay. Then I have Cl here and En here. Okay, this is one possibility. I can have one more possibility like this, NH3 here, Cl here, NH3 here and En here. This is one possibility. Next, I can also draw like this, Cl, NH3, sorry, En. This is one more possibility. What else we can do? We can have, just a minute, NH3 I did 2. Okay, here NH3Cl is there. I can draw like this one more, where I have NH3, this NH3, this is Cl, and this is En. Okay. Now, if I drew the mirror images of all these 4 structures, all of them will be optically active. So, if all of them will be optically active, so these are 4 geometrical and there will be 4 optical, so total 8 isomers I will get. Okay. Next, write all the geometrical isomers of PT, NH3, Br, Cl, Py type, and how many of these will exhibit optical isomers. So, now if you see here, yes, so if I draw this one, if it is of the type M, AX, Bl, suppose, okay, 4 different ligands are there. So, I can have like this, see, PT, Cl and Br is on one side, I have NH3, okay, and I have Py, okay, this is one. Next, I will take NH3 here, PT, Cl, NH3, you have Br and pyridine. Next, I have PT, where I will take Cl, I will take Py here, and here it is NH3 and here it is Br. So, you can see this, in this, this is cis and this is trans, okay. So, we have 3 isomers where I have 2 cis and 1 trans, okay. So, total 3 isomers are present, okay. Next, yes, NiCl4 minus is paramagnetic while NiCO4 is diamagnetic, though both are tetrahedral. Why? So, this is I will mark as an optional question, okay. So, if you see in NiCl4 what happens, NiCl4 has sp3 hybridization and 2 unpaired electrons. NiCO4 has sp3 hybridization with no unpaired electron. So, that is why this is paramagnetic and this is diamagnetic, because of the number of unpaired electrons present. Okay, next, okay, now on the basis of isomerism also, these are very, very important questions. Any one can be asked, okay. These are very, very important questions. So, you can just read the definition example, ionization isomerism, linkage isomerism, okay. Then linkage isomerism, you need ambidentate ligands. Ionization isomerism, when you ionize, you will get different ions. Then we have solvation isomerism and coordination isomerism. This is also there, okay. Solvent isomerism requires water. Coordination isomerism, you should have 2 different coordination entities. So, these all isomers you should prepare, and basically this is very important. Where is it? Yes, linkage isomerism is most of the time asked, and so please prepare linkage isomerism properly, okay. Next, we will move to, yes, electronic configuration and pairing of energy, okay. So, here what we have to do, see, if it can be asked for any configuration, so here you have to remember, if delta O is greater than pairing is given to you, that means in that case there will be no pairing of in that case there will be pairing of electrons, okay. Now, if delta O is less than pairing energy is given, in that case no pairing of electrons will take place. Okay, so for example, if it is asked, write the electronic configuration of D5 for delta O greater than P and delta O less than P. Okay, if it is given in this form. So delta O greater than P means you will have no pairing of electrons. So we have like this, 3 electrons here, 2 electrons here. There will be no pairing. So we will have 1, 2, 3. Sorry, there will be pairing. So we will have T2G5 configuration. Okay, and if delta O is less than this one, so we will have like this, 5 electrons you can do without pairing of electrons. So we will get T2G3 and EG2 configuration. Okay. अभी क्यों इतना काम है भाई? ठीक है,
3 बार उन्होंने बुलाया है, तो अभी उन्होंने बोला बुलाने को
3 बार मतलब
3 बार वो आए थे शायद, तक मैं भी नहीं थी वहाँ पे। तो उनको मीटिंग कुछ करना है, पता नहीं किस चीज़ का। तो उन्होंने बोला कि पहले सबको आने दो, पर अभी सामने जाके पूछना, बोला अभी बुला ही लो उनको, शायद तो उनको जाना भी है घर जल्दी से।
ओके, ठीक है, आती हूँ। कॉल किया था मेरे को? ठीक, मैं आती हूँ, ये ख़त्म करके आती हूँ। Okay, so these are the important questions from coordination chemistry. One question which I haven't discussed yet is the very important one which I actually forgot. Yes, 1 second, I will add here. So I want to add up, I will add up here. Okay, so please remember the very important question which is a must question, very important. Sorry, I didn't add in the slide, but I am telling here the structure, hybridization and magnetic property of NiCN4 2 minus, NiCl4 2 minus, COCl6 2 plus, 3 plus, and CONH3 whole 6 3 plus. Okay, so you should be knowing their diagram, geometry, hybridization, magnetic property and shape. So for NiCN4 it is square planar. Okay, and diamagnetic. Okay, next hybridization is DsP2. For NiCl4 it is tetrahedral and it is paramagnetic. Okay, and sp3 hybridization. For CONH3 whole 6 it is what it is, sp3d2 hybridization. Okay, then it is paramagnetic and octahedral. Now here also it is, you have D2sp3 hybridization, okay, and diamagnetic, and we have octahedral complex. Okay, so this you please practice it. I have given many questions how to write the answer. You can just practice it from the book directly. You have to write down. This is a very important question. Please do not miss it. Very sorry I haven't added in the PPT, but yes, please add it. Okay, now we'll be moving towards the next next one, that is biomolecules. Okay, now let us see the next chapter, that is biomolecules. Okay, so if we see this chapter, okay, yes, so here biomolecules you will be getting 1 2-marker question. Okay, 1 2-marker question you will get in the section B part. So for that, what all things you should prepare? The first one is the hormones and the function of hormones. Okay, very important. So this is also, you can say, a new question in the market, like that I can tell you. So this is important, okay, but sometimes it is not asked regularly. So yes, you should be knowing the hormones and their functions. So I have given you a table. So like for example, here the question is asked like, which hormone is responsible for external stimuli, which hormones are responsible to regulate the sucrose level. Okay, so these are the different hormones and their functions are there. So I have given you this table. So you have to take screenshot or you can write down and just mug up this functions. Okay, this is very important. So here we have, yes, these are the functions of different hormones. So please make sure that you remember all of them. This can be asked in your MCQs as well. Next question is again very important, structure of sucrose, maltose and lactose. So in 2-marker question, this will be very important. Any one structure might be asked. So you should be knowing their structure. I know it is again very difficult to memorize it, but yes, study it again and again and practice it, do it again and again, you will remember. Next we have essential amino acids and examples. So this is also very old and repeated question. So you should prepare essential amino acids that cannot be synthesized from the body, and example you can give any three, any one or two examples. Side by side you should also prepare non-essential amino acids. Okay, so if you know essential, you will know non-essential also, right? And its example also you should prepare. Next, reactions to show that glucose has 6 carbon in a chain and 5 OH groups. So these type of, there were 5 reactions of glucose, so you should remember all the 5 reactions and their conclusions. So for example, in this question, I will give you like, how can you show that glucose will have 6 carbon in a straight chain? How can you show that glucose contains carbonyl group? So you have to write the reactions for that. For straight chain, the reaction is with HI red phosphorus, and for carbonyl compound it is with NH2OH. Next we have the next thing, how can you show that the glucose has 5 OH groups, and how will you show that glucose contains an aldehyde group? So for 5 OH groups we have to react with acetic anhydride, and with for aldehyde you have to react with bromine water. Okay. Next we have, how do you show the presence of alcoholic group in glucose? Yes, so that is, how can you show the presence of that there is one primary OH group in the glucose molecule. So here we have what? Here we have the reaction on oxidation with nitric acid, glucose as well as gluconic acid yields a dicarboxylic acid. Saccharic acid, this indicates the presence of primary alcohol group. So it is with the what? Nitric acid. Okay, oxidation with nitric acid. Now here write the open chain structure of glucose. So this is not important, so I'll write it as optional, but yes, you should be knowing the open chain structure of glucose. Next, yes, this is important question number 100. Okay, what is denaturation of protein and which proteins remain intact? So loss of biological activity is denaturation of protein, and the primary structure remains intact. Next we have here vitamins and their functions and their deficiency diseases. So this also is very important question. It can be asked in your MCQs, it can be asked in your 2 markers as well. So vitamin A, that's deficiency, vitamin B1, their chemical names also please remember. From here 2 marker questions can be formed easily. Okay, so yes students, so these are some of the important questions from 2 marker. Okay, on the basis 5 marker questions we will be discussing in another video. So yes, now we will move to the next chapter. So students, now we will discuss the 2 marker questions from the chapter haloalkanes and haloarenes. Okay, so here also you will be getting 1 question of 2 marker, and what I have observed from the last 10 to 15 years of previous year question, this 2 marker question is generally a name reaction. Okay, so we will first discuss the name reactions, what all name reactions are there in this chapter. Fittig reaction, Schwartz reaction, Woods-Fittig reaction, Finkelstein reaction, Sandmeyer reaction. Okay, so these are the reactions from which this 2 marker questions can be asked. So the first one I have given you, this is your Fittig reaction. Okay, so I'm just writing the here. So when aryl halides reacts in presence of sodium and ether, we get Fittig reaction, diphenyl compound is formed. Okay, so this is the first one. Then I have also given you, yes, this is your Schwartz reaction, definition, and so whenever this 2 marker question comes on name reaction, first you have to write the statement and then you have to write the reaction. Okay, fluorides for the production of alkyl fluorides. Next, here we have your Finkelstein reaction. Okay, so sorry, so I have given you Fittig reaction, Schwartz reaction, Finkelstein reaction. So what is Finkelstein reaction? It is for the preparation of alkyl iodide. Okay, so if you take like for example CH3X in presence of NaI and dry acetone. Okay, so what will form? It will form CH3I plus NaX. Okay, this is done. Next we have the Sandmeyer reaction. So Sandmeyer reaction, what do you take? You take benzene disonium chloride. Okay, and you treat it with Cu2Cl2 HCl, that is your copper salt, and you will get here chlorobenzene, or you can take bromobenzene. Okay, now coming to this 2 reaction, that is Woods reaction and Woods-Fittig reaction. So in Woods reaction what we do? We treat Rx in presence of Na. In Woods-Fittig reaction, you take, see, Woods-Fittig reaction, you take Rx plus ARX. Okay, so I'm writing here. So you will get RAR. You can just see, but I have given you the list. So please prepare these name reactions. Now coming to, you may also get complete the following type reactions. For alcohols chapter, generally complete the following is given. But yes, here we have KNO2. Okay, so if you remember, KNO2 will give you ONO group. Okay, so this is your first one. Second one is what? This is your Woods-Fittig reaction, sorry, Woods-Fittig reaction. So you will get a diphenyl like this. Okay. Next, Sedzeff rule. This is also can be asked as a 2-marker question. So here what happens during dehydrohallucination? Okay, during dehydrohallucination of haloalkanes. Okay, what happens during dehydrohallucination of haloalkanes? More substituted alkene is formed. More substituted alkene is produced. Okay. Next we have aryl halides are less reactive towards nucleophilic substitution. So that is first one, resonance effect, and the second one is your sp2 hybridization of carbon. You can write these 2 points and explain it. Next, SN2 mechanism can be asked in this type of question where you have to just write the, so in SN2 mechanism what happens? Suppose I have Rx, okay, now nucleophile comes, right? Nucleophile will attack from the opposite side. So let me take here CH3, something like that. So I have like, okay, so nucleophile will attack from this side. So here what happens? Here a transition is formed, or we can say a transition intermediate is formed, and then it will form Nu. Okay. Next, we have what are freons, and name the poisonous gas evolved when Cl2 is oxidized by air. So freons, what the chlorofluorocarbon compounds of methane and ethane are collectively called as freons. And the name the poisonous gas when Cl2 is oxidized by air, that is called as phosgene, and the common name is carbonyl chloride. Okay. Next, I have what is chirality. You have to explain what is enantiomers. These are some definitions, so you should be knowing. So objects which are non-superimposable mirror images are called as enantiomers. Okay. Okay. So now what is enantiomers? I have written here. What is chirality? Chirality is the same thing. Like chirality is, okay, tendency of okay. Okay, so here I have written the definition. Objects which are non-superimposable mirror images are called as chiral molecules, and the property arising from them is called as chirality. What is the condition for chirality? It should have an asymmetric carbon. Okay, so what enantiomers also same thing, you have to write down the non-superimposable mirror images which are optically active are called as enantiomers. In haloarenes, para isomers have higher melting point as compared to ortho and meta isomers. What is the reason? That is because para isomers have symmetric, you can write due to the symmetry of para isomers. Okay, due to the symmetry of para isomers, they fit well in the lattice. Okay, so this can be the definition or can be the answer for this question. The main reason is the symmetric nature of the para isomers. Next, arrange the following in the increasing order of their boiling point. So we have bromomethane, bromoform, chloromethane and dibromomethane. So you can see first of all bromoform will have more because its mass is more. So first one I can write bromoform. Okay. Next you have dibromomethane. Okay. Next we have bromomethane. Bromomethane, and then we have chloromethane. Okay. Now 1 chloropropane, isopropyl chloride and 1 chlorobutane. So here what will happen? Here you can see 1 chlorobutane. 1 chlorobutane will have more mass, so that is having more boiling point. Isopropyl chloride and 1 chloropropane. So this is a straight chain, so that is why straight chain branching, if it is there, the boiling point will decrease, right? So we have 1 chloropropane and isopropyl chloride. Okay. Next, chloroform is stored in dark colored bottles. Why? So it is because CHCl3 gets slowly oxidized and forms a poisonous gas, that is COCl2. So that is why it is stored in, you can say it is stored in dark bottles to avoid its reaction. Now we will see alcohols, phenols and ethers, the very important reaction. So I can write this reaction is very important. Okay, so reactions of cumene. So cumene is oxidized in the presence of air to give you cumene hyperperoxide. Now it is converted to phenol by treating it with dilute HCl. So this reaction you have to write, and this statement you can write. This will give you 2 marks. Next, Williamson ether synthesis. When alkyl halides on treating it with alkoxide ion in alcoholic medium gives ethers. This reaction is called as this reaction is called as Williamson ether synthesis. You can take one example like this: CH3O minus Na plus reacting with CH3Br gives here CH3OCH3 plus NaBr. Okay. Next we have this one, reaction with copper. So this one, when reacts with copper, there will be oxidation, right? We will get here ketone. And here if we treat it with zinc dust, okay, so if you treat it with zinc dust, you will get benzene. Okay. Next, identify A and B in the following reaction. So O minus NaFCO2 is there. So in alcohols, phenols, ethers, I have generally found you will get such type of reaction based questions. Okay, so this one will give you what? First one, this one will give you benzoic acid. Okay, this is your Coles reaction, or I can say salicylic acid, sorry, not benzoic acid, salicylic acid. Now here with HI, you can see this side tertiary is there. So this one will form iodoalkane and this one will form your alcohol. So I will get CH3 whole 3 Ci. Okay. Next, boiling point of alcohols are higher than the other classes of organic compounds like hydrocarbons, ethers, haloalkanes of comparable molecular mass. Give reason. So this is your, because of hydrogen bonding, alcohols are more soluble in water. That is also due to because of hydrogen bonding. This can also be asked in 2-marker question. Next we'll come to something, Lucas reagent. How do you distinguish between primary, secondary and tertiary alcohol? By Lucas reagent. So Lucas reagent is what? It is a mixture of ZnCl2 and anhydrous H2SO4. Okay. Now how does it react? Primary will be having no reaction. Okay. In secondary you can write it will react and turbidity is observed. Turbidity is observed after 5 minutes. Okay, and tertiary one, what will be happening here? In tertiary one, there will be immediately turbidity is observed. Immediately turbidity is observed. Okay. Next, this is from your commercial alcohols. What is rectified spirit, absolute alcohol and denaturation of alcohol. So anything can be asked as a 2-marker question. So you should be knowing the definition. Rectified spirit is 95.5% of ethanol and 4.5% of water. Absolute alcohol is 100% pure ethanol. Now denaturation of alcohol is what? When the commercial alcohols is made unfit for drinking by adding copper sulfate and pyridine. Okay, that is, and methanol, that is called as denaturation of alcohol. Next, we have among orthonitrophenol and phenol, which is having higher pKa value. Okay, so sorry. So if you see, orthonitrophenol has a electron withdrawing group, right? Because of electron withdrawing group, you can write like this: orthonitrophenol has electron withdrawing group and hence more acidic. and hence more acidic and more acidic means less pKa value. So that is why which will have higher pKa value. So phenol has higher pKa value. That's all you have to write, has higher pKa value. Okay. Next we have, how do you prepare aspirin from salicylic acid? Give the IUPAC name of aspirin. Okay, this is also, I think this is a important question. Okay, but yes, again aspirin you should be knowing. Salicylic acid reacts with acetic anhydride in the presence of concentrated sulfuric acid to give aspirin, that is 2-acetoxy-benzoic acid. Okay, so we have this one, that is your compound name. So yes, so this reaction you should be knowing. Okay. Next we have orthonitrophenol is steam volatile but paranitrophenol is not. Explain how to separate ortho and paranitrophenol. So orthonitrophenol is having intramolecular hydrogen bonding, paranitrophenol is having intermolecular hydrogen bonding, right? So orthonitro is steam volatile because of intramolecular hydrogen bonding. How to separate ortho and para? You can separate them by using steam distillation. Okay, so these are some of the small questions. Yes, this is very important question again, VVI. Cole's reaction you should be knowing, and you should write the statement as well as the reaction. So what happens? Sodium phenoxide reacts with carbon dioxide followed by acidification to give you salicylic acid. Next we have Reimer-Tiemann reaction. Okay, so here also first you have to write the statement. Phenols on heating with chloroform in the presence of sodium hydroxide at 340 Kelvin followed by hydrolysis gives you orthohydroxybenzaldehyde. This reaction is known as Reimer-Tiemann reaction. Okay, then the reaction has to be mentioned. Next, what happens when diethyl ether is heated with limited HI and excess of HI? You have diethyl ether. Okay, so if I have like this, you have diethyl ether. So when you treat it with HI, bond will break somewhere and I will get CH3 CH2 OH plus CH3 CH2I. Okay, now if you do excess of, so once this product is formed, now if you treat it with excess of HI, what will happen? This one will get protonated and then I will replace this one and you will get CH3 CH2I. Okay, so 2 CH3 CH2I will be formed in case of B, and here first you will get alcohol and iodoalkane. Okay. So yes students, these were the most important, most repeated questions for your 2 markers and 3 markers from the chapters, that was your solutions, kinetics, and then DNF block, coordination, and biomolecules, haloalkanes and alcohols, phenols and ethers. Okay, electrochemistry as well. So yes, you can prepare these questions. Okay, so these are like most important questions, so do prepare them, and if you have any doubt, please put down in the comment section. I will definitely address to it. And thank you for watching, and do not forget to subscribe the channel.